I remember a couple of students asked me to record it, so I want to not forget. Okay, ready? So we wanted to graph y equals 3 sine, I forgot, 3 sine.
3 sine 1/2 x.
Very good. So now if you remember a long time ago, we talked about changing x in f of x. We can get an f of 1/2 x or an f of twice x. And I said this is the only transformation that is not self-explanatory, or it's not straightforward, or we may come up with something that is totally opposite of what we expected. So when I change x into 1/2 x, I really expect this. But that's not the case. It's exactly opposite. When I change x into twice x, I really expect this, but it doesn't happen. It's this. So this will be the first transformation on sine x. Don't write anything just now for 1 second. So I know that this is sine x. Right? Now, 1/2 x does not divide x by 2, multiplies x by 2. So instead of the period 0 to 2 pi, what would be the period now? 0 to 4 pi. So first of all, so this is 2 pi and this is 4 pi. Sorry, thank you. Okay, so first of all, this was the initial period of 2 pi. Now this function will have a period of 4 pi. So I'm going to graph just this for a moment. Okay, so instead of crossing here, it will cross here. So this will be the graph. And we'll show this with a graphing calculator in a minute. So this graph is sine 1/2 x. Now I need to graph, I need one more color. I need to graph 3 times that. What does the number outside do? The number inside, when I change x into 1/2 x, it does this. When I change x into 2x, it does this. But what if I have a 3 outside? What will that do? This is straightforward. This is not the opposite. Right. Instead of the height to be at maximum, what is the maximum possible for sine? 1. And what is the minimum possible for sine? Where will that graph go now? To 3, and where will that go down? Exactly. So this point, instead of being at 1, 2, we're right here, and this one was at -1, -2, -3. This point will be here. So this is the new graph. We did not have time for this. So of course you're not going to see something like this. I didn't have time to go in detail for sine and cosine, but let's do it with the graphing calculator. It's not, we learned all these transformations, but since I did not have time to present this, you're going to not see this on the final exam. I can't put it on the final if I didn't present it in class. Although it follows the rules from chapter 2. There is nothing new, but I didn't get the chance to do transformations on this function other than shift left and right. So let's go to the graphing calculator and put in 3 functions in y equals. So the first function is our sine x. The second function is sine 1/2 x, so like 0.5 times x. And the third function is 3 times sine 0.5 x. Do not hit enter yet. Why? Because we need to adjust the viewing window and the scale and everything. Okay. What do I want to see from 0 to 3? Careful. We're not talking about y yet. We are talking about x. So from 0 to 2 pi, the function will go from 0 to 4 pi. So 4 times pi. Pi. Thank you. With the scale, let's put it pi. I'm going to have 4 units. 0, 1 pi, 2 pi, 3 pi, 4 pi. Okay, now how low should y be? Right, but I'm going to go to -5 because I don't want to have an edge, the graph at the edge of the viewing window. And I'm going to go to +5 with a scale of 1 is good. Now I'm ready to click on graph. It's going to happen very fast. So you'll see the first function quickly in one color, the second function a different color, the third function a different color. We already graphed them. We know what to expect. So let's press enter. Here, oh, ha ha ha, mode. What is the problem? What did I forget to say? Of course. It must be in degrees because it looks awful and I know the graphs. And nobody can fool me with this. Please stop. Okay. Of course it's of course the mode is in degrees because I don't see the graphs that I know I expect. So enter, and now let's graph again. Here comes sine. It will show 2 periods now because we have 0 to 4 pi. Here comes sine and 1/2 x. It occupies from 0 to 4 pi. And here comes 3. Up to 3, down to -3, and back to 0. Which we knew. Is this okay?
Mine has like a weird, it's like, first 2 are right, but then it has,
We have to see this. You forgot the sign on second function.
oh,
It's okay, just insert it. So the blue is sine x. I didn't need 2 periods, but because I had to present 0 to 4 pi, it shows one and then the other. And then the red one is the stretched because it's 1/2 x, the opposite of what we would expect. And then the 3 is normal. We did all this, but I didn't have time to practice. So if I don't have time to practice, I can't put it on the test. Good, very good question, excellent. Thank you. Other questions from me? Anything else before we go back to chapter 4? Is there anything else? Brittany, I think you said you had something or not?
I can't remember now.
Okay, that's okay. That's okay, you will remember.
I have one more thing.
Yes, yes.
When you're finding the coterminal,
Yes.
you have to find like a multiple of 360.
Well, it depends. Give me the angle. Let's
Well,
see.
the angles, okay, if it's -765.
Very good. So first of all, I have to start here, and I have to go in clockwise, right? Because it's negative. These are positive angles, and these are negative angles. So yes, so this is -360. Okay, so -360 was -360 is -720. So obviously, I have here -720. And now I know how much more I need. So I need 45 more. 45 more is right in the middle of a 90 degree. So it has to stop right here. So this is the initial side, and this is the terminal side. And now I can find as many angles as you want that are coterminal with this. They can be positive, they can be negative. So which one you want? You want the positive or a negative?
So are we supposed to find both?
If the problem is asking us both, then we find both. If it's asking us just to find the positive, then we'll find positive. Let's find both.
Okay.
So if I'm asked to find a positive angle, it will be this. 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. Or
That thing is twisted or something? Because it looks like the little screen is just like,
really? This is better? Sorry about that.
Okay, I guess you have doubled up the paper.
So I know that this is pi over 4 or 45, right? So 1, 2, 3, 4, 5, 6, 7. Or I will say 7 times 45 and I calculate what that is. So this is one angle. It starts here, it ends here. Now the other angle that I could create, or there are infinitely many, the other angle that I could determine is a negative angle, which is negative pi over 4. And negative pi over 4 and 7 pi over 4 have the same initial side and the same terminal side. So they are coterminal. All these three are coterminal. This, and this. They all start at the same point and end at the same point.
So this is the one where like you would take 720 minus 40 or 365 45 and find an angle, which is 315.
The negative, so I have,
Well, define the one you just did.
you mean this one?
Yeah.
The red one?
Yeah.
Yes, because I know that this reference angle is 45. So there are two 45s here, two 45s here, two 45s here, and two 45s here. Because this is a 90. And this is a 90, this is a 90, this is a 90. So if I want the positive angle, I would count 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. And if I want the negative angle, then I just go this way and I have negative pi over 4. If I want to find another one, I'll say negative pi over 4 minus 2 pi. That will be a fourth angle, coterminal. If I want another one, I'll say negative pi over 4 minus 2 pi minus 2 pi. That's another angle coterminal with the previous ones. As long as they start and end at the same point. Is that, did I answer your question?
Yeah,
Or not really?
not really.
So what was,
So you have, so it's negative 765. So I did 720 minus 765 times the negative 45, which is the one same.
that's fine,
Okay. So it's the same thing.
same thing.
Okay.
But I still have to picture the angle first.
Right.
So I know where it ends and which quadrant, yes. Other questions? Is there anything else? Is there anything else, or can we go to chapter 4? Chapter 4? I'm looking at the review. It starts on page 510. From 4.1, again, I could not narrow it further than the tests. I mean, if you practice the tests 10 times and you get 100% or you grade yourself to 100%, it's impossible not to be able to get an A in this class, on this final, right? So just, that's the narrowest that I can go. If you do the quizzes and the homework problems, you should be able to teach this class. Next semester I come in and I'll say, Sammy, teach. And I'll sit here and take a nap. Okay, from 4.1, I recommend a graph of an exponential function and a word problem, like, for example, 11. Okay, and problem that we just started with that 3 x minus 2 minus 9. So let's look at, so this is from 4.1. Graph the function 3 to x minus 2 minus 9. And I will ask you to present the x and y intercepts, the asymptotes, or whatever, everything about the function. Here's what I would do. First, I will say, okay, let me quickly graph this function using transformations. I know that the base function is 3 to the x. I know how to graph it. It's increasing on all its domain and it passes at 1. Because when x is 0, y is 1. Then I know that this is a shift to the right of 2 units.
Sorry, what page are you on?
Oh, I just made this
Oh,
up.
okay, now.
No, this particular one I made up.
Okay.
But we're on page 510. So this is 3 to x minus 2. And what do I do next? Down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know that this function has a horizontal asymptote at y equals 0. So it must be moved now to y equals negative 9. This point that was at 2, 1 will be at 2, -8, because it moves down 9. So here it is. So this is the graph of 3 to x minus 2 minus 9. I don't know where this is, and I don't know where this is. So I don't know the x and y intercepts. I have to calculate them. But there is no problem. I will set x equal to 0 to find the y-intercept. 3 raised to 0 minus 2 is 3 to -2. So g of 0 is 1 over 9 minus 9. So this is -80 over 9. So this point here is 0, -80 over 9. And now to find this point, what do I do? We set y equal to 0, right? For the x-intercept, I set y equal to 0. For the y-intercept, I set x equal to 0. So I have 0 equals 3 to x minus 2 minus 9. I move 9. I have 3 squared equals 3 to x minus 2. And I said that a million times, and I know I repeat myself. You do not simplify by 3. You don't divide by 3. You don't eliminate 3. No. You just say two numbers are equal and they have the same base. What must happen? The exponents have to be the same. So x equals 4. So then my graph was off. It should have crossed here. So I go back and make my adjustment. So now I know that the x-intercept is 4, 0. And this is more than enough for me to know that you know what the exponential function is all about. Problem 11. In problem 11, suppose that you have $14,000 and you invested over 10 years. And it's 7% compounded monthly, or 6.85% compounded continuously. These two formulas will be given to you. So here they are. A equals P, 1 plus R over N to NT, or A equals P e to RT. So this is for continuous, and this is for monthly. What does N represent when we talk about monthly? N equals how many months in a year? 12. Very good. So let's punch them in. And that's really all we studied in 4.1. I don't think there is anything else. So then A equals 14,000 times 1 plus 0.07 divided by 12. Everything raised to 12 times 10. The other one for continuously compound interest, 14,000 times E to 0.0685 times 10. So we punch in 14,000. In parentheses 1 plus 0.07 divided by 12. Close the parenthesis, power or caret. And in parentheses I have 12 times 10. I'm going to just say 120. And press and enter. And the other one is 14,000 multiplied by E. Careful, here it is, right here. And in parentheses 0.0685 multiplied by 10, which I could have performed, but anyway. So I get that the first one gives us 28135.26, and the other one 27772.81. And I know I should conclude what? That compound interest in this particular situation at 7% gives us a bigger return than the continuously compound interest at 6.85% for 10 years. From 4.2, let's graph a log and domain. So I may ask you something like graph the function f of x log base 2 of x minus 2 plus 2. I will ask you asymptotes if they are, a domain, everything will be mentioned. So I will have to start with the domain. How do I find the domain of a log function? Or what can log be applied to? Oh, yes, log can be applied only to what type of number can this be? Can it be -3? Okay, let's say we forgot. So let's go to the graphing calculator. And I don't have base 2, but I have base 10. So if I put -3 in here, I'm checking, right? And I press enter. Okay, I go back, and let's say I put in 0. It has to be positive. So the quantity we apply log to must be a positive number. Otherwise, log does not exist. So I move 2 to the other side, so x has to be greater than 2. Therefore, the domain must be this. So when I finish graphing the function, I cannot see anything to the left of 2. Of course, x equals 2 will be a vertical asymptote. Good. So again, quickly, I graph the function using transformations. I know the first function is log base 2 of x. I know the next one is log base 2 of x minus 2. And finally, log base 2 of x minus 2 plus 2. So how do I graph log base 2 of x? Is it increasing? Is it decreasing? Increasing. And it looks like this. Because 2 to the x looks like this. This is 2 to the x. This must be log base 2 of x. They are symmetric with respect to y equals x. Good. Now, how do I graph log base 2 of x minus 2? To the? Very good. So this point, which was at 1, moves at 3. But so does the vertical asymptote. The vertical asymptote was at 0. The graph shifted 2 to the right. I have to shift the vertical asymptote as well. Exactly. So now here's the graph. And this is log base 2 of x minus 2. Now, what is the final step? Up 2. So this point goes up here. And this is the new graph. Or the final, f of x. Does this graph, is it clear why the domain is 2 to infinity? Mm-hmm. Does this graph cross the y-axis? No, but it crosses the x-axis, and I can determine this point as an ordered pair. How do I determine the x-intercept for any function? I set y equal to 0. Very good. So then I have log base 2 of x minus 2 plus 2 equals 0. I know how to solve this equation. How? What do I have to do first? Very good, thank you. So I have log base 2 of x minus 2 equals negative 2. I need to convert this into something I can handle. And what is that? Always starting with a base, going counterclockwise.
Oh.
Raised to 2 raised to negative 2 equals x minus 2. So this is 1/4, and I move 2. So x equals, what is it, 9/4. So this point is 9/4, comma 0. I like to find one more domain for a log function and then look at a word problem here. Let's say problem 42, page 511. So we have a function f of x equals common log, which is base 10 of 3 minus x. They're asking us to find the domain of this function. What do I have to write? Of course. Absolutely. 3 minus x is greater than 0. And what do I write now? Moving 3 to the other side. And then what do I do? Very good. So the domain of this function is this. Problem 48. Student in psychology, same page, on 511. Student in psychology class, in a psychology class, took a final examination. As part of an experiment to see how much of the course content they remembered over time, they took equivalent forms of the exam in monthly intervals thereafter. The average score f of t for the group after t months. So t is in months. F of t is score. For the group is modeled by the function f of t equals 76 minus 18 common log t plus 1, and they are giving us t to be between 0 and 12 months. What was the average score when the exam was first given? What is the average score when the exam was first given? Part B. What was the average score after 2, 4, 6, 8, and 1 year, which is 12 months? And then they want us to graph this function. So what am I asked to determine? Say it again. They're asking.
When t is 0.
Exactly. That's the initial. That's always the initial. And then in part B, they're asking us to find 2. What else? One more time. 2, 4, 6, 8. 4, 6, 8, and 12. Now, when t is 0, how much is 0 plus 1? How much is log of 1? 10 raised to which number is 1? Exactly. This will be 0. How much is 0 times negative 18? How much is 0 plus 76? That's it. So that was the score. Now we need the calculator for the rest. So in y equals, clear, please. Okay. And we put in 76 minus common log, no, there was an 18 in there. 18 common log in parentheses t plus 1, which is x plus 1 in our calculators. And now I go back to second and table. Please, table. Okay. You can punch in 0 again if you have any questions or doubts about that. And then I'm going to put in 2, 4, 6, 8, and 12. So I'm looking at the scores. So roughly 76. 76 was the first one. 67 is the second one. Then 63. And then roughly 61, I'll say. 59 and 56. And now in part C, they're asking us to graph this function. So let's graph it first with the graphing calculator. So I have the function. Now I go to the viewing window. X minimum 0. What will be x maximum? It was given in the problem between 0 and 12. Very good. Now, y minimum, and the scale of 2, that's fine. Y minimum, it cannot be lower than 0. So I'm going to put 0. And y maximum, I know y maximum. 76. Okay, so I'm going to say 80. And then with the scale of 10. So let's graph. Okay. So from 76 and down to what? 56, 12 months later. That's what they really wanted us to plot those points in part C. So if you want to say this is 76, I'm going to say this is 56, and this is what the graph does between 2, 4, 6, 8, 10, 12. This is the graph. Now from 4.3, it's condensing and extending. That's all we studied in 4.3. So let's choose a problem. Let's say 56. In 56, we have 3 natural log x plus 4 natural log y. We're asked to condense this into one log. What will we do first? Exactly. I have to address the number in front first. Excellent. Yeah. Oh, I have all sorts of things in my papers. Yes, I have to write natural log x to the third plus natural log y to the fourth. Yes. And then, since both logs have plus in front, excellent. Very good. Okay, now the next section was about equations. All sorts of equations, exponential and logarithmic, and the last section was on more word problems. Okay, please choose anything you want from 64 through 79, and then we'll look at word problems. Good pick. 5 raised to 4x plus 2. 71 on 511. 5 raised to 4x plus 2 equals 500. Perfect. I don't know if 37500 is a power of 5, and I don't care. The number is too big for me to worry about it. So, what do? Yes?
Like, um,
Very good. We want to apply common log to both sides. So 5 raised to 4x plus 2 and common log to 37500. Perfect. Now, I must bring the power in front, and it has to be in parentheses. If I forget or omit parentheses, I mess up the whole thing. Log 37500. Now you have two options. You could divide both sides by log 5 and then subtract 2 and divide by 4. Or you could distribute. It's up to you. It doesn't matter. If you want to distribute, it will be 4x log 5 plus 2 log 5 equals log 37500. I will move this term here or to the back. It doesn't matter. So 4x log 5 equals negative 2 log 5 plus log 37500. And finally, I have to divide both sides by. The top is negative 2 log 5 log 37500. And of course, I have to divide by the two numbers. Yes, 4 log 5. I will put it in the graphing calculator to see what I get. Very carefully because you need I did something to this.
So you're dividing.
This is a number. This is a number. So I have to divide by it.
That everything but x.
Right, because I'm solving for x.
So you just took the X out.
I'm solving for x. Yeah, I have to get rid of everything else. So now, in parentheses, negative 2, common log, 5, in parentheses, close, plus log 37500. Close. Close again the parenthesis for the top. And now we're dividing. Parentheses again. 4 log 5. Close the parenthesis and close the parenthesis again. And press enter. 1.136 roughly. 1.136. I want to check my work. How do I check my work? Right. So here's what I'm going to do. I'm going to do this carefully. So careful how you put it in. So it's 5 power in parentheses. We have 4. Recall the previous answer. That's not what I meant. 5 power in parentheses. 4. Recall the previous answer. And then plus, it was plus, yes, plus 2. Close the parenthesis. When I hit enter, what should I get? 37500. Yes, if I don't, there is something wrong. Okay? So I know now for sure, I don't need anyone to tell me that this is indeed the correct answer. Approximately 1.136. Okay. Let's also look at a log equation. If we have time, we'll come back to more. I'd like to go back to chapters 3 and 2 as well. Let's say 77 on 512. So log base 3 of x minus 1 minus log base 3 of x plus 2 equals 2. Remember, when we solve log equations, something is very important. What? We either state the domain, or we say, forget domain, I don't want to do domain, but I promise that whatever I get, I'll go back and plug it in. Which one do you want to apply? It doesn't matter to me which one, but you have to choose one. You either state the domain and then you don't have to worry, you just check against the domain, or you say, I promise that I'm going to check, because otherwise I have to deduct it a little bit if you don't check. I completely agree. And it's a good practice because the domain is very important. What is the domain of this function? Minus 1 must be What is the domain of this function?
X plus 2 greater than 1.
Good. So this means greater than 1, and this means greater than negative 2. So greater than negative 2, this is greater than negative 2, and this is greater than 1. And I have to choose where they both are fulfilled. Okay, let's do this. So this is 0, negative infinity, infinity. This is greater than negative 2. And this is greater than 1. Of course. So x must be greater than 1. If I get something that is not strictly greater than 1, if I get something that is x equals 1, it has to be disregarded. It's not possible. It has to be strictly greater than 1. These cannot be equal to 0. Good. So now I'm ready to condense the left-hand side. So please condense the left-hand side. How do I condense? Very good. Very good. So remember, the difference changes into log applied to a ratio. The sum changes into log applied to a product. Okay. So then from here, excellent. Very good. So then I have 9 over 1 equals x minus 1 over x plus 2. And I know what to do next. Exactly. So 9x plus 18 equals x minus 1. Now I subtract 1x. I subtract x, I get 8x. And I subtract 18, I get negative 19. So I get x equals negative 19 over 8. What do I conclude? No solutions. Got a solution that is not strictly greater than 1.
How did you get 3?
3 squared equals this. The base raised to this number equals this. This is the most important topic or idea, I would say, in this chapter, that an exponential equation can be changed into a log equation can be changed into an exponential, and an exponential can be changed into a log. So base raised to this number must equal this number. Better? Yes.
I was just writing it down.
That's okay.
X is negative 19 over 8, and that is...
So I subtract x, and I subtract 18.
And it's no solution because it's less than 1.
Yes,
Okay.
exactly. Okay, now let's look at some word problems. Uh, 88 on page 512. The function f of t equals 500,000 over 1 plus 2,499 e to negative 0.92 t. Models a number of people in a city who have become ill with influenza T weeks after its initial outbreak. So T weeks. First question, how many people became ill with the flu when the epidemic began? What am I asked to do first?
17.
Yes. So f of 0. Let's do this together. Maybe we can cut back on writing. How much is negative 0.92 times 0? How much is e raised to 0? 1. How much is 1 times 2,499? How much is 2,499 plus 1? 2,500, right? And now how much is 500,000 over 2,500? Yes, exactly. 200 people were ill initially, became ill initially. Part B, how many people were ill by the end of the 6th week? So f of 6, that I don't know. I have to punch it in. I will not be able to do this. in a million years without a calculator. So 500,000 divided by parentheses, careful, 1 plus 499 multiplied by e raised to, in parentheses again, negative 0.92 multiplied by 6. Close the parenthesis for the power, go outside and close the parenthesis for the denominator. And press enter. So at the end of the 6th week, 45510, I cannot round up, even if it's 0.72 when it comes to people. So 45410. Part C. What is the limiting size of the population of f of t, the population that becomes ill?
500,000.
Yes, because as t approaches infinity, this will approach 0, and 0 times this will be 0, so it's f of t approaches 500,000 as t approaches infinity, which this is the concept, but we can't really say that t approaches infinity, but that's what they're asking us to do. Okay. Yes, I want to look at the exponential decay problem as well. 87. Same page. Use the exponential decay model. A of t equals a0 e to negative kt. Well, it's kt, they wrote it, but it's decay, so it's going to be negative in front. To solve this exercise, the half-life of polonium-210 is 140 days. Half-life, 140 days. How long will it take for a sample of this substance to decay to 20% of its original amount? So I'll put in parentheses, to decay to 20% of the original. So that's my question. That's the question that we have to answer. So we have to do something with this half-life because we do not know K. Now, as I said, the model is given as a plus. We will have to find K. That will end up being negative. Okay, so what is the concept of half-life? I know that this is the original mass because when t is 0, this is 1. K, whatever it is, K times 0 is 0. E to 0 is 1. So when A is 0, this is the initial. No doubt about it. So half-life, I know that in 140 days, the initial amount that I have of polonium-210 will become half of it. So this becomes half of A0 in 140 days. How do I write that? So when t is 140 days, A of t is A0 over 2, half of the initial. And this is what I have to put in. A0 over 2 equals A0 times E to 140K. So whenever I'm given a situation like this, it means that the mass in 140 days will be the initial divided by 2. So if we have here 10 milligrams, in 140 days, this becomes 5. If we have 100, in 140 days, this becomes 50. If we have A0, in 140 days, this becomes A0 over 2. Is that clear? Okay, what do we do now? Yes, I have to solve for K, but I have to get rid of this. So So if it's better or easier for you to see, just change 1 over 2 in 0.5. A0 equals A0 e to 140k. But you have to see that you need to get rid of A0, otherwise you will not be able to find k. So now we will have to apply natural log or common log, it doesn't matter. Let's say natural log. And now I can get k. So put it in the calculator. Natural log 0.5 and divide by 140. And now I have the model. So the model is A of t equals A0, which I don't have, e to negative 0.005, I would round it up, t. And this is the model. And now I can answer their question. The question is, find t so that the initial, which is A0, becomes 20% of A0. So I start with A0, I have 100% of A0, it drops to 20% of A0, and I want to find the time. How do I do that? So this is basically, half-life is from 100% A0 to 50% A0. It's half-life. Now I want from 100% A0 to 20% A0. How do I write that?
0.2.
Exactly. A0 equals A0 e to negative 0.005 t. You could have answered from the elevator if you had known the question, right? Good. So I get rid of A0. So then natural log 0.2 equals negative 0.005 t. So then t equals, remember I don't write times natural log e because natural log e is 1. I should write here times natural log e. But natural log e is e raised to which power is e? The base is e, right? For ln, the base is e. E raised to which power is e? E raised to which power is e? 1. That's why I don't write it here anymore. So this is natural log 0.2 over negative 0.005. So natural log 0.2 divided by, you can recall the previous answer if you want to be as exact as possible. And I just did that. Let's see what happens. I got 325. So t equals 325 days for polonium-210 to decay to 20% of its whatever mass we start with.
So you always have to start with
For the half-life,
the half-life.
if it's given. I may or may not be given the half-life, but if I'm given the half-life, most probably I'm not given K.
Oh.
I'm not given the decay rate.
So we have to find.
So I have to find the decay rate. So initially, so I'm really told that from 100% to 50%. And that happens in 140 days.
So when we're finding K, we have to put A is equal to 0.5.
Yes, 50%. 50% of A0. Yes.
And A0
Is the initial value, whatever it is. I can start with whatever amount. I can start with 50 milligrams, or I can start with 100 milligrams, or I can start with 5,000 milligrams. The process does not depend on the amount because it's all about percentages in this kind of question.
So okay.
Go ahead.
I'm just trying to figure out like why we had to put 0.5 A0 because that's A0 is
Yes, because when I say I have in my pocket 50%, you should say That's insane. 50% of what? So I have to say 50% of what you have. If you have $100 and I say I have in my pocket 50% of $100, it means 0.5 times 100, it means I have 50. So when I am asked to find the time it decays to 20% of the original, I am told 0.2 times A0 of the original means. Here for the half-life, I'm really told 0.5 times A0. So percent doesn't mean anything. If I say, again, I'll say my house is 20%. And you have to say 20% of what?
I guess I'm confused, like what A0 is supposed to do.
A0 is the initial amount of radioactive substance.
So is there a problem where they give us A0?
Yes.
Okay.
Let's look at a problem in which...
I remember those. I don't
No, that's a very good point. Let me go back to 4 or 5. It's a very good point. And let me find a problem in which it can be radioactive decay or it can be growth model. Like, for example, 35 on page 505. Very good point.
Are we going in a certain order right now?
Yes.
Or just answering?
No, we're going in a certain order, and the order is backwards. We're finishing up chapter 4 to go back to 3 and 2. No, that's okay. So we have A of t, the growth model, which is 4.3 times e to 0.01 t. Describes New Zealand's population, A, in millions, t years after 2010. So this is the population in millions. T is 0 for 2010. What is the New Zealand's growth rate?
0.01.
Exactly. So R or K, in some books is R, and some books in pre-calculus I write R, in your class I have to write K. It doesn't matter how you want to call it. Is this, which is 1% per year. Okay, so that was first question. Part B, how long will it take New Zealand to double its population? It's pretty much the same thing with saying, what is a half-life, which is not the case because this is a growth, it's not a decay. But it's the same pretty much.
Multiplied by 2.
Right, so what am I going to write?
What was the initial?
I'm asking you, what is the initial?
know.
4.3. To double it will be what? 8.6 equals 4.3 times e to 0.1 t. So see, in this case, the initial population was doubled by meaning it's 200%. When its half-life is 50%. So that's the difference. And here I was not given this. I don't have to be given this either. I don't have to, because I can put 2 times A0. So assuming that this is not given to us, I'm just going to call it A0. So then I have 2, A0 equals A0 e to 0.01 t. No, it's not going to make any difference. The time that it needs to be doubled, it does not depend on the initial population. So then I have natural log 2 equals 0.01 t. From here, t equals natural log 2 over 0.01. So that amount didn't even mean anything. So natural log 2 divided by 0.01. And it turns out that it needs roughly 69 years for the population to double. At any point in time, you can start with any value because it doesn't matter, you'll divide by it. You have here 4.3, you can start with 900. The answer will still be the same because this will be 900, this will be 2 times 900, and you'll still simplify it. So the initial population doesn't, is this better?
Okay, yeah, and then, okay, so it's 8.6 equals 4.3. And then we put,
When you divide both sides, you have to divide both sides by 4.3 and you'll still get 2. You cannot apply natural log in this case. You have to divide both sides by 4.3.
so divide 8.6 by 4.3.
No, 4.3. You have to separate the variable from the rest, so you have to get rid of this. So you have to divide both sides by 4.3, and 8.6 divided by 4.3 is 2. That's how we got 8.6.
Yeah, okay,
Multiplying 4.3 by 2.
and then it'd be 2 equals,
Yeah, 2 equals e to 0.01 t, and then you apply natural log.
oh,
Can we go back now to chapter 3? We only had 4 sections in chapter 3. Okay,
I don't know what chapter it was in, but I was doing the quizzes.
Very good. Do you remember which problem?
And it was quiz 10, and
Okay.
I just have when you add functions and subtract functions
Okay.
and multiply and
Okay.
divide.
Yes?
I know that for adding them, subtracting them, and multiplying them, there's one common domain for those.
Right.
And then when you do the dividing,
No. There is a common domain that you have to determine from the beginning. That common domain will always be the domain of the sum, difference, and product. When you determine the domain of the ratio, you still start with the common domain.
I understand that.
Okay.
And then you set it equal to 0 and
And remove-
on a number
yes.
line, see where they overlap. But is that modified domain, is that just for
Just for the ratio.
the ratio? The other 3,
Will never
Will have
change. Will
the-
never change.
the
The common domain.
common domain?
Yes.
Like just the ratio.
The
of one
ratio could
that
have,
you have overlapping on a number line.
the ratio could have the common domain, only if the denominator will never be 0. So let me give you an example. So if I have, for example, this, x plus 1, which is f, and x squared plus 1, which is g, this ratio will have the common domain because this quantity is never 0. But if the ratio ends up to be something like this, then x cannot be plus or minus 2. So from the common domain, I have to remove plus or minus 2 in order to determine the domain of the ratio. But otherwise, it will be the
And
common.
that only applies to if it's a ratio.
If it's yes, only for the ratio. Only if the denominator can be 0. If the denominator cannot be 0, then all 4 functions have the same domain, the common domain.
So I was confused over that before, but
Is that okay now?
so but all other 3 would have
Always the common domain.
And then the only different one that has to have
Could be.
both
Could be.
Well, it's saying that it is not, that it is 0, can be 0. Okay.
Yes. On page 435. So what is the chapter 3 all about? Number 1, quadratic functions, which are separate, polynomial but separate, cubic, 4th degree, and rational functions, and inequalities. That's all we studied. Where are the inequalities? Yes, in 3.6. Yes. So 3.1, 3.2, 3.6, 3.5, and 3.6. 4 sections. So let's start with quadratic functions. 3.1. Number 7. Do we have to graph a quadratic function, or are we okay with graphing quadratic functions?
Let's go just real quick.
Say it again.
Let's do one.
Yes, okay, very good. Let's say problem 3 on page 435. why did I write this instead of this? Okay, f of x, negative x squared plus 2x plus 3. We're asked to graph this function, and I will list all the requirements for graphing. So here they are. First of all, the shape. Since the leading coefficient is -1, the shape is a maximum. Then number 2, the vertex. I have to remember that the vertex is negative b over 2a, the first part of the quadratic formula, negative b over 2 times a, so this is 1. And the y-coordinate is finding f of 1. Negative 1 plus 2 plus 3 is 4. So now in step 3, I want the x-intercepts. How do I determine the x-intercepts?
Set up x equals 0 and solve.
Correct. So I have y equals 0, so negative x squared plus 2x plus 3 equals 0. I refuse to solve a quadratic equation with a negative leading coefficient. And then I factor easily. So I get two options, x equals 3 and x equals -1. And I do have two ordered pairs, 3, 0, -1, 0. Then I have to find the y-intercept. How do I find the y-intercept? I find f of 0, indeed, which is 3. So 0, 3. And the last two, number 5 and number 6, are just words, basically. I will say that x equals 1 is the axis of symmetry. I wanted to write a vertical asymptote for some reason. And y equals 4 is the max value. These two come from the vertex.
Always.
Yeah, it's the axis of symmetry and the max or the min. Yes. So number 10 I have here. So when I graph a parabola, I graph the vertex.
That's only if the if it's a
It's a maximum.
is less than
Yes. Yep. Correct. So this is the axis of symmetry, which is x equals 1, 0, 3, -1, and 3. So here's the graph. Try to make it as symmetric as possible. So this is f of x, negative x squared plus 2x plus 3. Yes?
Step 5, y equals 1 was the axis,
The vertical line passing through the vertex.
which is the symmetry, right?
Axis of symmetry, yes.
And then the y equals 4.
Is the maximum value. Is the maximum value
How do we get that again?
from the vertex. 1, 4.
Oh, okay.
And then the range, what will the range be?
-30.
Very good. Good. Problem 7. A quarterback tosses a football to a receiver 40 yards downfield. The height of the football f of x in feet can be modeled by, so this is problem 7, the same page. F of x equals -0.025 x squared plus x and plus 6, where x is the ball's horizontal distance in yards from the quarterback. What is the ball's maximum height, and how far from the quarterback does this occur? How do I find the maximum, and how far does it occur?
Just need to find the vertex.
Exactly. Every time I'm given a quadratic function and I'm asked to find max or min, then I know that cannot be anything else. So I have to find negative b over 2a. Negative b is 1. 2 times a is -0.05. And this is 100 over 5 when I multiply top and bottom by 100. So this is 20. So 20 is the horizontal distance. But now what is the maximum height? Exactly, f of 20. So I'm going to do this with a graphing calculator. Negative 0.025 multiplied by 400 plus 20 and plus 6. Okay, I got 16. So 16 feet max height. From what height did the quarterback toss the football? Set?
equals 0.
Exactly. F of 0 is 6 feet. Height that the quarterback threw the ball from. Okay, part C, last question. I'm sorry, there is a part D as well. If the football is not blocked by a defensive player nor caught by the receiver, how far down the field will it go before hitting the ground?
Find the x-intercept.
Of course, thank you. So I have to find f of x equals 0, negative 0.025 x squared plus x plus 6 equals 0. I refuse to solve a quadratic equation with a negative leading coefficient
Why?
because I don't want to put in the quadratic formula with a negative in the bottom. I may forget about it. Who knows what I do? So I would like to divide actually by 0.025, negative 0.025. So I have x squared, 1, so this is negative. How much is 1 divided by, this is 1,000 divided by 25. So it's 40. Correct me if I'm wrong, please. And 6 divided by that is 6,000 divided by that. So it's 6. So 6 divided by 0.025. How much? 240. Thank you so much. Okay, so now I can use the quadratic formula. Minus 4ac plus 4 times 240 divided by 2a. So now in the graphing calculator, I will have in parentheses 40 plus the square root of 40 squared plus 4 times 240. Close the parenthesis. Go outside, close another parenthesis, divided by 2. And then I will copy this. And I expect this to be a negative number, behind the quarterback, in other words. And I change this into minus. Yes. Okay. So roughly,
Why do you want the negative intercept?
I don't, but I would like to see both because I know I have a quadratic equation has 2 solutions. Of course I don't. I don't need it. But any quadratic equation has 2 solutions. So I will say x equals 45.3 feet and x equals negative 5.3 feet, which is disregarded. However, when I graph it in a moment, because that's what they want us to do now, here's the graph. So I have to go 45. I'm going to say 10, 20, 30, 40, 45. How high? To 16. 2, 4, 6, 8, 10, 2, 4, 6. Okay, so here's my graph. So this was 2, 4, right? 6. So that's, so when I can extend this, which I will not, I will get this. Okay, so then at 20 horizontal distance, so this was 20 right here, the height is 16. So here's the graph. So here's the quarterback, and he throws the ball like this. And this is the axis of symmetry, and this is that 20 that we're talking about, the horizontal distance, and this is the maximum of 16 feet. Okay, now in 3.2 we talked about cubic, 4th degree, 5th degree, 6th degree, whatever. So which one would you like to graph? Any questions on this? Is this okay? Okay, problem 22 then, on page 436. So I have f of x equals negative x to the 4th plus 25x squared. We're asked to graph the whole thing. Oh, I forgot, we also had 3-3, the long division and the synthetic division. So we had 3-1, 3-2, 3-3, 3-5, and 3-6.
Make sure I don't think we did the long division synthetic.
I think we used it once. Yeah. Slant asymptote. Yeah, okay, very good. So I have to establish the degree, and I have to start with the, say it again, careful. Careful. Yes, degree is 4. So what is the maximum possible turns? Max possible, doesn't have to turn 3 times, but max possible 3 turns. 1 less than the power, than the degree. So what is the degree, the domain of a polynomial function?
Negative 20 times.
Thank you. So now I take that function and I do what with it? Factor out, yes, what?
X squared.
Negative x squared. Very good, excellent. So then I have x squared minus 25. Now I factor x squared minus 25 into x plus 5, x minus 5. Perfect. So now I know the solutions, and I expect 4, because the degree is 4. 2 of them are exactly. One is 5, and the other one is negative 5. This is a regular cross. This is a regular cross, but this is a turn. So I have 0, negative 5, 5, 0, 0, 0. And I make myself a note, turn, cross, cross. So now the end behavior. I'm looking at this. I know that the degree is even. Exactly. Exactly. I agree. Negative infinity to negative infinity. Now, is this function symmetric?
Yes.
Yes. When I replace x by negative x, what do I get? The same thing. What does that mean? That the function is symmetric with respect to?
With respect to the y-axis.
Exactly. It's an even function, symmetric with respect to the y-axis. Perfect. That's all I really need. You can find other points if you want to. There is no need. Good. I plot my points, and here they are. And yes?
Did you want, I mean, I think I know what it's gonna be, but did you want to find the y-intercept? Don't you usually?
Because the graph passes through 0, 0, that is the, yeah. So I look at my chart. It's coming from negative infinity. It crosses the x-axis at negative 5, 0, regular cross. But it must have a turn because it has, I know it has to turn here. And it does not cross the x-axis again. So it has to have a turn because it has to come back and turn at 0. I don't need the other side to look there because it has to be symmetric with respect to the y-axis. So what I graph here I have to graph here. Identical. The only thing I don't know is this, which has to be the same with that. But everything else is clear. Now I need the graphing calculator. I have to put it in
The maxes.
to find the max, yes. So in y equals, I will put in negative x to the fourth and plus 25x squared. And at the viewing window, I know I don't care about the negative side. I already have the graph. So between 0 and 10 will be enough. With a scale of 1, that will be enough. Y minimum, I need like, let's say, negative 7 to positive 7 with a scale of 1. Because I know the graph. I only need to make some room to find the maximum. So I press graph. And I realized, oh, I didn't punch in negative. I probably didn't. Let me check again. But I realize now that here it's clear I have to adjust anyway. Y minimum negative 7. Y maximum. Oh, yes, of course. I just did the reverse. Sorry. Sorry about that. Negative 7 to 7 with a scale of 1. Y minimum negative 2, and I already saw that I have to go probably to 50 with a scale of 5. So negative 7, 7 left and right with a scale of 1. Y minimum negative 2, I don't care about below. Y maximum, I don't know if 50 is good enough. We'll see in a moment.
The scale, is that just the units?
These
in
bars,
between
these bars,
the little
these bars right
notches
here.
or whatever?
Just these bars, these ticks. This is the scale.
So it would be each one is equal to X.
Whatever it is, that scale that you choose, yes. So I have to go back.
Do you have to change that a lot, or?
If you want to have a decent graph, yes, I would recommend it. Change it based on what you need.
Do like max 200.
200? Okay, very good. Thank you. So now I can determine the max. I know it's somewhere between negative 5 and 0. So with second and calc, I want the maximum, which is number 4. Between negative 5 and 0, and I don't want to guess. And the maximum is negative 3.5. I'll put in my chart.
156.
156.25. Can anyone give us the other maximum without the other point without
3.5.
exactly 3.5 and 156.25? It has to be because the function we know, and that's one of the important idea that we gain from knowing that the function is symmetric. I don't have to work that hard to find the other. I already know what it is. Okay, let's look at rational functions 3.5. Any particular one you have in mind? Is it type 1? Is it type 2? Okay, problem 60 on 437. On 437. R of x, they say, is x squared plus 4x plus 3 divided by x plus 2 squared. Okay, what type of function is this? Right? It is type
Second degree.
type 1. The
Oh,
numerator,
type 1
the
because-
numerator is degree 2. The denominator is degree 2. Very good.
So that means the horizontal asymptote
Would-
would be 1 divided by 1.
Exactly. Absolutely. So you can already write that. So 1. So y equals 1 is a horizontal asymptote, and of course in the same on both sides. But what is the domain of this function?
Would be set x, actually x.
Very good. X cannot be -2. Since -2 does not disappear with the factor from the top, even when I factor the numerator, how do I factor it? Yes, very good. Into x plus 1 and x plus 3. So I have r of x can be also written as x plus 1 over x plus 3 over x plus 2 squared. Since x equals 2 does not disappear with the factor from the top, I know for sure that x equals -2 must be vertical asymptote, which guarantees infinities left and right. What I don't know, though, is the sign of that infinity. Good. So let's try with -2.1 and -1.9. In this form, this is easier. So with -2.1, -2.1 plus 1, sign.
Negative.
A -2.1 plus 3.
Positive.
And this doesn't matter. Okay, so negative times positive, what should I put here?
Negative.
Now -1.9. -1.9 plus 1. Negative. -1.9 plus -1.9 plus 3. And still negative. When is this function 0? When is a ratio 0 always? When
Y-axis when it hits the y.
when the numerator is when is the fraction 0? When is a
the numerator
is 0? Well, when is the numerator 0?
at -3 and -1.
Very good. Be very careful how you put it in, because they have to be in order. -3, -2, -1, 0. And now please punch in 0 in this function. These two are 0, and this is 0. The top is 3, and the bottom is 4. So 3/4. Ready? Is this function symmetric? If it has a vertical asymptote at -2 only. Can this function be symmetric? No. Any questions? Yes, Sammy? This one? When x is 0, 0, 0, the top is 3, 0 plus 2 is 2, 2 squared, 4. Very good. So now let's attempt the graph. When I graph a function with asymptotes, what do I have to graph first? The asymptotes first. How many asymptotes does this function have? 2. So I have to graph, yes,
Vertical, one horizontal.
I have to graph y equals 1, and I have to graph x equals -2. Now I look at my chart and I follow what my chart is telling me. Ready? At -3, 0, -1, 0, and 0, 3/4. This is 1, 3/4 is here. Oh, so sorry. One more time. -3, 0 is here. -1, 0 is here. And 0, 3/4 is here. Ready? So I read the first part before the vertical asymptote. From approaching 1, crossing at -3, 0. How do I know it's crossing and not turning? Well, with this multiplicity is 1, right? So it has to cross. So from approaching 1, crosses here and goes to -infinity. From approaching 1, crossing at -3, 0, approaching -infinity. On the other side of the vertical asymptote, from -infinity it crosses at -1, 0. How do I know? Because it's multiplicity 1. And crosses again at 0, 3/4, the y-axis, and goes towards 1. And that is the graph. Any questions? Yes.
Okay. I'm trying to, okay, so from negative infinity,
You mean, are you on this side
okay, no, wait, I'm starting from the beginning, so,
from here?
yeah,
From approaching 1, it has to cross at -3, 0, and it goes to negative infinity.
so
From approaching,
approaching 1 is the y equals 1.
yes, but I cannot say that it is 1. I have to, because it's a horizontal asymptote,
Okay, and then it crosses and goes,
to negative infinity.
and why am I confused? Okay, I have a 0 in there though.
Yes, -3, 0 is this point.
Oh, okay, negative 3, and then it goes to negative.
To negative infinity.
And then from,
Negative infinity on the other side crosses
oh,
at,
they were both negative?
yes. Yes, we determined they were both
Yeah,
negative.
and then it crosses over, wait, crosses -1, 0.
Yes, and then 0, 3/4, and then approaches 1.
Okay,
Better?
yes.
I would like to look at, let's say, 74 on 438. 74. 438. X plus 3 over x minus 4 less than or equal to 5. Ash, you have a question? Okay. What do I do? And let me say this, do not write anything. I'm going to be silly. So if you multiply both sides by x minus 4 and you write x plus 3 less than or equal to 5 times x minus 4, I will have to give 0 points and I'll move on to the next problem. Can anyone explain why?
Sorry, what did you do?
Multiplied this side by x minus 4 and I got x plus 3. Multiplied this side by x minus 4 and I got this. And I claim that this is not allowed and I will give 0 points. Why?
Didn't,
You didn't change the sign?
Exactly, that is the point. I don't know. I don't know if this is positive. I don't know if this is negative. I don't know when to change the signs. I don't know if to change the sign. So that's why this is not allowed in an inequality. I'm not allowed to eliminate a denominator that has x in it, ever.
So
What will I do?
I subtract 5.
Exactly,
Both sides.
exactly. So please remember that. This will be a terrible mistake to make. Yes, I have to find the LCD, which is, very good, x minus 4. What is the adjustment that -5 needs? Very good. And then what do I get at the top? I get an x plus 3. I get -5x and plus 20. And when I simplify at the top, I get -4x plus 23 over x minus 4 less than or equal to 0. Now, whatever you use, my chart or another chart or your method or any method, but you have to show something.
so much easier than the way the book tries to say it.
I think so. You're checking. False, true, false, true. But as I said, maybe that's an easier method to put in writing than this one. I don't know. So -infinity to infinity. I know from here it's a 4, but this one is weird, right? It's 23 over 4. Which one is bigger? So 23 over 4 is roughly 6, right? So I'm going to put 4 first, and then 23 over 4. Then I put a 0 here under 23 over 4, and a 0 here for x minus 4. When x minus 4 is 0, this must be undefined. And when x is 23/4, the fraction must be 0. But now I have to study the sign. You can plug in numbers if you want. But remember, this is a linear function with a negative slope. It has to come from positive and go to negative. There is no other way. So you can plug in a number if you want. But this is a linear function with a positive slope. It has to go from negative to positive. So when I divide positive over negative, I get negative. When I divide positive over positive, I get positive, and here I get negative. So finally, I'm asking myself, what do I pick? I have to pick the negative, right? So I have to pick between negative infinity and 4. I cannot close at 4. I have to leave it open at 4. Union, yes. Now I can close at 23/4 to infinity. One more chapter to review, which is chapter 2. Everyone did exceptionally well on chapter 2, so I don't know exactly what would you like me to review in chapter 2. I'm sorry? I only have 18 minutes, that's why I want to select. One of my friends' battery died and he's stranded somewhere, so I have to pick him up sometime after 3 o'clock. Yeah, he's waiting for me. Because he's going... Which one?
Chapter 2 is like slow.
Let me tell you what it is. So if you start by looking on page 323. Piecewise defined functions. I would like to graph one. Evaluating functions. Difference quotient. So we have time to do a difference quotient. Yes, slopes and lines. Finding domain and common domain, exactly what Eric just said. Finding the inverse of a function that is 1-to-1. Can't think of anything else. So what would you like me to do first? Difference quotient, piecewise defined function, distance, midpoint. Piecewise, very good. So let me make one up. So let's say we have f of x, which is x squared minus 1 for x less than or equal to 1. And negative x plus 2 for x greater than 1. First, I have to identify what, without which I can't find anything. Exactly. So to the left of 1, 1, and to the right of 1. So what is the domain of this function? All real numbers, right? So I have to have 1 in the problem. To the left, it's closed. To the right is open. Which function will I use on this interval? Very good, x squared minus 1. Which function will I use on this interval? Perfect. So the left one is quadratic. Do I know how to graph x squared minus 1 without even thinking? I don't even write anything. I know x squared, and I know x squared minus 1, right? So when x is, so it will cross at negative 1 and 1, right? And go to negative 1 as the minimum. So plug in negative 1, please, and tell me what to write. Exactly. Please plug in 0 and tell me what to write. And please plug in 1. Right. So we knew that. On the other side, please plug in 1. and plug in 2. Perfect. So let's graph.
And
Yes.
1, 0, and 2, you just pick those because they're
Because I know how to graph x squared, and then I know how to graph x squared minus 1. So negative 1, 0, 0, negative 1, and 1, 0. Full point. This is the quadratic function on the left-hand side. Now, on the other side, I have to graph from 1, 1, which is this, and then 2, 0, which is this. Of course, if you make this mistake to continue here or graph this function to this side, I will have to consider 0. This function has to stop here. It's between negative infinity for x and 1 for x. This function has to start here and goes to the right. Has no place on that side. Like this one has no place on the right. This one has no reason to go to the left.
But
Yes,
the domain is still, the range is still.
all real
infinity
numbers.
to
Yeah,
positive
yeah,
infinity.
yeah, because you have the function or both at any point in time. Okay. Do we look at a difference quotient, or we're okay with that? Do we look at difference quotient? Okay. So, bless you. So let's say f of x equals negative 2x squared plus 3x minus 8. The difference quotient will be given to you, f of x plus h minus f of x divided by h. So we're asked to determine it and simplify it. Which of these 3 pieces I do not have, and I have to determine? Exactly. I do not have this piece. So I have to find f of x plus h, which is negative 2 x plus h squared plus 3 x plus h minus 8. So negative 2. How many terms do I get when I square x plus h? Okay, if you say 2, then you're going to get 0. Plus 2xh plus h squared plus 3x plus 3h minus 8. Please remember, a binomial squared is a trinomial. Please, please. So negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 8. So now we are ready.
What did you say not to do? I'm sorry.
Not to say that x plus h squared equals 2 terms. We made a contract 3 months ago.
Which I still don't understand what that means.
In other words, x plus h squared does not equal x squared plus h squared. Does not.
You have to distribute it. The FOIL.
Okay, but I prefer using the formula.
Oh, yeah.
But yes, I agree. Okay, so then I have to copy f of x plus h, which is negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 8. But now I have to distribute -1 to these three terms. So plus 2x squared minus 3x and plus 8. And now I hope a lot of them go away. And all terms with no h have to go away. Now I see 1, 2, 3 terms. They all have h. I will have to factor it out so I can get rid of it. -4x, -2h, and plus 3. And that will be final. Ash, do you have something in mind? I want to answer something for you too.
No, it's okay.
Did you have anything in mind? You do have something?
Yeah.
Anything else?
You're gonna give us all the formula with, right? Well, not all of them. but,
Which formula do you have in mind?
Like the decay.
Oh yes, those will be given in the problem. Oh yes.
And that one will be given.
Yes, yes, the difference quotient, yes, will be given in the problem. Yes, absolutely, yes. I will say, find the difference quotient and I'll put it in for this function and simplify it, yes.
So what formulas do we have to know?
You need to know transformations, what they mean and where they go. And you need to know the quadratic formula. You need to know how to factor, the factoring formulas. You need to know the 3 properties that the log has and the change of base formula. You need to know what multiplicities mean. And say it again.
Would you have like do an index card?
No, because then I have to look and see, and it has to be uniform for everyone. So yeah, you can't have problems on that. So.
Well, I mean like just with the formula.
Right, but then it will take me an hour before we even start to check everybody's index card.
What's the change of base again?
Yes, the change of base. So if you want, let's say, to determine log base 7 of 3, then you will say natural log 3 over natural log 7. So, or log 3 over log 7. So the denominator is from the base and the numerator is from the number.
So that just makes it.
So then you find this and you find this, put it in the calculator and you'll get an approximation.
And that's because you can't do log the base, so you can only do base 10.
The new calculators actually have that option, but I think the new calculators have that. I don't know if your calculator has it or not. See, it does. This calculator has it. My calculator does not. So here you can, I guess you can put the base, the base you want.
Okay, log.
Yeah, so you could use that. I don't have that in my calculator. Yeah, mine too. Not even in the 86. I don't have that feature.
So you're gonna post this as well as the suggested homework problem?
I was looking at that even last night. I just cannot narrow it even further from the tests and what the recommended problems are. So
So
I just do the tests and the quizzes and the homework. Yeah, and our homework.
And you're gonna post this.
Yes,
you
right
mean-
now,
you mean
right now.
returning homework.
Yes, the homework that we turn in, yeah.